We're going to talk about light now. Light can be considered a wave and a particle. As a wave, light will go through some different things that we'll investigate further. 3 of those is reflection, refraction, and diffraction. Now, reflection is when a wave strikes a surface and bounces back. Refraction is when the wave hits that surface, it enters into the new medium, the new material that it hit. You may have heard refraction referred to as bending of the wave, and I want to talk to you more about how that can be misleading. Diffraction is when a wave wraps around a barrier, and you may have heard diffraction referred to as a scattering of light. Now, as a particle, light is called a photon, and it will transmit energy. And we call this transmission of energy the photoelectric effect. And the photoelectric effect is when particles of light transfer energy. Now, what's interesting is not all colors of light transmit the same amount of energy. So red versus blue on a sheet of metal, if we allow these 2 lights to shine on this metal for a certain amount of time, then the red light will not produce electricity or free electrons flowing through the metal, but the blue light will. So blue light transmits more energy than red light. Okay? Now I want to look in more detail at reflection and refraction. The first thing I want you to notice is that reflection always occurs at the same angle as the incident ray. So in the green I have the incident ray striking this brown boundary that marks the boundary between my 2 substances. So we could say this is air and this is glass. Now, when the incident ray strikes the surface, the reflected ray will always bounce back at an equal angle. So the incident angle and the reflected angle are always equal. It always is true. Even on an uneven surface, reflection will happen, and the reflected ray will bounce back at the even angle that the incident ray hit. Now, the difference between an uneven surface and a smooth surface is whether we see an image or not. So I want you to understand that every object has reflection happening to it. Reflection, a lot of times we use that word to talk about the image that we see in a mirror. But the true scientific definition for reflection is simply all waves hitting a surface and bouncing off. In order to get an image, these light waves would have to bounce off in a regular pattern. And when that happens, we will see an image. Now, if this substance allows light to pass through it, then we will talk about refraction. Refraction is when light enters a different medium. Now, whenever it goes to a different medium, light will either speed up or slow down. If it goes through a material that has more resistance to waves than the material it was leaving, like air to glass, then the refracted ray will be smaller than the incident ray. And we would say that the speed of the wave has slowed down. Okay? Now, if the refracted ray is greater than the incident ray, then the speed has increased. So this could be like going from water to air, and this could be going from air to water or air to glass. And we'll look more at that in class. Now Now, light waves are not always able to enter into a different medium. And we talk about the transparency of a substance to determine whether or not light waves can enter into the material. If a substance is transparent, we will be able to see clearly through it, which also means that the light is able to pass clearly through it, is able to go through. So glasses on my face, windows on the house or on the car, these are all transparent objects that allow light to pass through them. Now, translucent is when you have that frosted effect. I have blurred up here because a lot of people will use that terminology when they're describing translucent. If you can imagine trying to hold a newspaper behind these two different types of glasses, I would be able to read the newspaper behind the transparent glass. I would not be able to read the newspaper behind the translucent glass. Now, opaque is when the substance appears solid. It's like milk or tile. You cannot read or see anything through it. Now, while we're talking about transparency, we also need to talk about luminous and illuminated. All objects can be seen. Some of them are seen because they produce their own light, and some are seen because they are reflecting the light that hits them. Luminous is when you produce your own light, like the sun. Illuminated is if you are seen by reflecting light. So luminous is when you produce your own light. Light bulbs, flashlights, candles, all of those are luminous. Anything else is illuminated. Now let's talk about mirrors and lenses. Both mirrors and lenses have concave and convex types. A concave mirror or lens is the one that curves in. These little markings here represent where the wall is. So over here is the real world, and behind here is the virtual world. I curve in for a concave and I curve out for a convex. Now, in a lens, we use concave lenses to help nearsighted people because their problem is they converge the light in their eyes too quickly. So they need something to scatter the light and take longer to form the image on the back of their optic nerve. So we use concave lenses for nearsighted people. Farsighted people take too long to converge the light waves on the back of their eye, so they need something that will bend the light towards them, towards their optic nerve faster. So we use a convex lens to correct farsighted vision. Images can be produced with mirrors and lenses, and there are three ways to describe our images. We can talk about the location, the size, and the orientation of the image. Now, location will either be real or virtual. Size will either be same, enlarged, or reduced. Orientation will be either upright or inverted. Now, the key is that when you are describing an image, you should have one of each of these in your description. So a real image is the one that is formed in the real world. A virtual image is one that appears behind the mirror or the lens. Size, I think, is self-explanatory, and orientation is upright if the image stays the same as the object, and inverted if it's in the opposite orientation of the object. So I could have a real, same size, inverted image, or I could have a virtual, enlarged, upright image, or I could have a real, reduced, inverted image. And so as we create some of our images in class, please be sure to use one word from each category.